Okay, I've got the metal bar here preheated to 230 Fahrenheit. Just gonna put that in there and then torque that to 2.5 Newton meters. And I torque it just so I don't spin the captured nut. And then I need to stretch that spring as I come over here. So I'm just gonna put that in and then just get this hand tight to start. And come back with my torque wrench. Take that to 5 Newton meters. And now we are ready to twist. That's 5 twists right there. Now the overshoot, and then the spring back. And that's a twisted piece of metal right there. So let me undo this clamp. That's going to jump back a little bit, but that's okay. No biggie. Loosen that clamp up. Let's see what we did here. So we got the flat preserved where it was in the clamp right there to spec with our hole and our twist. Nice and straight. So this other bolt is also a captured nut into a flat on this shaft. So this is a 25 millimeter shaft with 2 tapered roller bearings and these 2 bearing blocks. So it's pretty big stuff. It's like the kind of stuff you'd use on a go-kart. So pretty overbuilt in that respect. And then those 2 bearing blocks are kind of just braced by this plate, and it's also kind of a decorative plate with my client's name on there. Speaking of overbuilt, we've got a NEMA 23 2.8 Newton meters here, going into a 50-to-1 gearbox, going into a 2-to-1 reduction pulley system here, with a HTD 5 millimeter pitch belt. So 100-to-1 reduction there, or 280 Newton meters possible torque. I believe I'm only using about 100 of that. And then going over here to the electronic side, I've got my microcontroller in there on top of my stepper driver. And I'm micro stepping at a 16th on top of that 100 reduction. So it's actually 160,000 steps per revolution. And I'm stepping at about 20 kilohertz. So very, very fast step rate. Switched AC inlet IEC cable, 48 volt on my stepper power supply there. And then another 5 volt power supply here just for my low voltage on my microcontroller. And then my outlets, my Hall sensor connection. So embedded in the back of this clamp, you can see down in there is my Hall sensor. So I can actually twist to an exact number of twists. And be sure that I hit that number. So it's a kind of closed loop in that sense. And then this one is my motor. And then this one is my controller pendant. So I've got 2 buttons here. One will take it to the home position, which is just the next time it senses that Hall sensor. And then the play button here will twist it the programmed number of times. It's programmed to 5 twists right now. And then we'll overbend it by an amount that you set in the software and then bend it back to that Hall sensor. And then this is also magnetized, so the operator can just click it to the faceplate or click it wherever they want